Good afternoon, everybody. This is Dadhich, and welcome to my presentation on impact of collaboration cluster formation on carbon and cost savings in horizontal collaboration. A recent statistics from Department for Transport shows that 30% of vehicle kilometers are on empty, and vehicles are utilized to only 61% of their weight capacity in the UK. This trend has remained steady in recent years, representing an opportunity for companies to look beyond their organizational boundaries to reduce the number of empty trips. There are many solutions to improve vehicle utilization, and one of the effective way of vehicle utilization improvement is through horizontal collaboration between companies. This can be defined as bundling of transport resources of companies operating on the same level of the supply chain who may have similar or complementary transportation needs. Bundling of transport resources can provide multiple benefits, such as increased asset utilization, cost reduction, better customer service, and improved efficiency level. So the distribution costs can be reduced by up to 30% cost savings and up to 54% carbon savings in the road freight transport. However, there are many barriers which hinders horizontal collaboration implementation, and those barriers include identifying the right partners, ICT requirements, trust and transparency, negotiation with partners, and determining and dividing gains. From an economic perspective, determining and dividing gains is a difficult barrier to resolve for many companies. Freight transport companies need a clear understanding of how these gains can be determined and divided among collaboration partners. Cooperative game theory has been applied in several studies to understand how these gains can be determined and divided among a coalition. However, these studies lack information on coordination costs to investigate its impact on coalition formations. So the main research focus here is to develop a framework to identify coordination costs of horizontal collaboration, identify which coalition formations are likely to achieve the lowest cost in carbon emissions when the coordination costs are taken into account in the UK FMCG sector. Vertical collaboration is more common in the UK FMCG sector compared to horizontal collaboration. There is a better integrated system between suppliers and manufacturers, and this is something which is rarely seen in the horizontal collaboration scenario. Companies find it more difficult to collaborate horizontally, especially in the secondary distribution because of the increased complexity of delivery timings and also frequency of deliveries. Cost and carbon allocation in horizontal collaboration requires transparency as it may lead to failure of collaboration if there is no proper sharing of information. Cooperative game theory method provides a framework to analyze which coalitions will form and hence the payoffs participating companies can obtain. These payoffs decide which collaborations are likely to form, how gains can be divided in coalitions, and whether these outcomes are robust, fair, and stable. There are some studies that have focused on coalition formation and determining dividing gains through cooperative game theory for cost allocation problems. And also there are some studies which has implemented cooperative game theory in logistics. These studies are by Van Overmeer and Sorensen. This study mainly focuses on the reward organizations in a collaboration that can provide flexibility in delivery time windows. Lozano analyzed several cooperative game theory methods and also analyzed the benefits that you can receive by merging the transport flows. First calculated transportation cost and backhaul of a collaborative forest transportation problem, and Krajewska analyzed cost reduction opportunities for the third-party carriers, the savings they can receive by forming a coalition. Allocation of carbon emission to cooperating partners has been seen more recently in the literature. Carbon emissions are applied just as a part of cost function for carbon allocation. And for carbon and cost allocations, Shapley value can be used. So Shapley value is mainly used for the average marginal cost of participating players if the participants are entered in a random order. So the main aim of this cooperative game theory method is to uh, distribute the gains in a fair manner. There are a lot of papers which discusses about the application of Shapley value in logistics. However, still many collaborations fail in real world, and barriers limit scalability of collaboration. So what we have seen in the real world in the literature is there are only some companies who are forming collaborations. We won't see many studies more than 2 or 3 companies who are involved in a coalition at scale. As mentioned in the paper of Lozano and Guajardo, as the size of collaborative group grows, coordinating cooperation will become more difficult as coordination cost increases, and also as the complexity of managing those collaboration increases. Still, there is less focus given on coordination cost in literature, which has the potential to outweigh any benefits from small size companies. So, in this context, I mean the coordination costs that are involved in horizontal collaboration. So what are these coordination costs? There are only few or less articles or papers which have described coordination cost in horizontal collaboration. But coordination costs are defined in literature of buyer-supplier relationship and outsourcing relationships. So in buyer-supplier, these costs of coordination include exchanging information on products, price availability, demand, as well as the cost to exchange design. In outsourcing, these coordination mechanisms include sharing forecasts and schedules, standardized information system, communication, and this can also be represented in terms of time, effort, and resources of the outsourcing organization. So the literature usually approaches horizontal collaboration from a static point of view with no mention of coordination cost. And it also mentions that these costs are quite complex to calculate. Here we are using a theoretical framework of transaction cost economics to identify the costs involved in horizontal collaboration. Transaction costs are the expenses resulting from selecting an appropriate exchange partner, negotiating and crafting contracts, resolving conflicts, and revising the existing agreements. These transaction costs can be categorized into setup and process costs. The setup costs include search cost and contracting cost. The search cost includes identification of new partners in collaboration. Contracting costs can include what kind of contracts are involved. So that could be contractual or relational. And in these contracts, what is the cost of sharing of resources, cost of sharing of information in terms of data and setting up of IT systems, the charges involved in the logistics administration, and costs involved in the transport, packaging, and handling. So when the coalition is set up, the other so in terms of methodology, the data was collected from 27 FMCG companies from a project that was done in 2010. And it included origin and destination postcodes, frequency of movements between origin and destinations, quantity moves, and the kind of vehicles used. The analysis included basically the transport flows which had less than 15 pallets in the vehicle, so those flows can be consolidated. A cluster analysis was performed to identify the depots and distribution centers in the close proximity that could deliver to customer postcodes, and that radius was 35 kilometer. The transport costs were calculated using a network design tool, and that is based on heuristics algorithm and linear programming. And the cost and carbon savings were generated by bundling of those individual transport flows. The cost savings and carbon savings were calculated using a CGT method called Shapley value, and the coordination costs were calculated using an incremental convex function that helped in identifying correlation formation and cost and carbon gains. So I won't go in detail of Shapley value, but it's important to say that it allows distribution of the gains in correlation in a fair manner. And the main properties of Shapley value are the efficiency, individual rationality, symmetry, dummy player, and additivity. The coordination costs were calculated using a convex incremental function, which is mentioned on the screen, and those were deducted from the coalition savings by the companies. So this Pareto distribution in this slide shows cost savings achieved by each coalition sets. So y-axis represent cost savings and x-axis represent all the coalition sets. As you can see on screen here, Grand Coalition is the coalition of 6 companies, and that represents highest cost savings compared to all the coalition sets. Similarly, in this graph, the Pareto distribution shows carbon savings achieved by each coalition sets. And again, as you can see on the screen here, the Grand Coalition of 6 companies represent highest carbon savings. To summarize this, this slide shows the cost and carbon allocation of 6 FMCG companies. So this table provides a description of final set of coalition, which involves 6 companies. So out of 27 FMCG companies, only 6 companies had compatible flows that could be combined. So these transport costs were calculated by bundling of those flows, and that represented transport savings. So here you can see that the transport costs are described here, and the cost allocations, the carbon emissions, carbon allocation. The important part is that the percentage relative cost savings and carbon savings are shown. So that means all the companies were able to save cost and carbon. And if we summarize this table, Grand Coalition can provide 27% cost savings and 31% carbon savings when there are no coordination costs involved. This slide shows coalition cost savings from base scenario. So in this base scenario, there is no coordination cost involved. And what we have done is that we have got coordination costs that are increasing from 10 to 30% on the y-axis. The experiment shows that when coordination cost of 10% is considered, the Grand Coalition still provides best cost savings, but when you look at 10% cost savings, then still Grand Coalition can be formed. However, Grand Coalition is not the best scenario when coordination costs are increased to 20% and so on. Also, coalitions with less companies are likely to continue receiving cost savings. For example, if you look at the set of S1, S2, S1, S2, S3, and S1, S2, S3, S4. But as you see, if you keep going to the right, that means the coordination costs are increasing, and that means you won't get that much carbon savings if you keep increasing the coalition sets. Although the Shapley value is the best way to divide gains in fair and transparent way, it does not guarantee the stability of a coalition. It is still possible for certain coalition to benefit by forming new coalition. That doesn't mean that companies won't have any benefits in joining the Grand Coalition. However, this will lead to formation of clusters of horizontal collaboration instead of one grand coalition. Also, if companies decide to form a grand coalition, these coordination costs will offset any benefits from collaboration, particularly for companies with lower marginal costs. So in terms of discussion and conclusion, cost and carbon savings were achieved by each player in Grand Coalition. Grand Coalition can provide 27% cost savings and 31% carbon savings when there is no coordination cost incurred. Collaboration clusters are likely to form, and sub-coalitions are likely to form when coordination costs are higher or equal to 20%. So our future work will involve a survey to understand coordination costs of collaboration in a coalition. So this is an ongoing research and will find uh, basically setup cost and process cost involved in the coalitions. And also we'll look at the cost allocation in backhauling and multi-drop deliveries with time windows. Thank you very much. And please let me know if you have any suggestions or feedback or any questions. Thank you.